Okay, topic here going to be some kites and some trapezoids. Our central question says, what are the properties of kites and trapezoids? And how are problems solved with them? Okay, so after concluding his investigation of special parallelograms, our guy Euclid, the father of geometry, turned his eyes towards other types of quadrilaterals. He proved many theorems about kites and trapezoids. We're going to start off with the kite. What's a kite? A kite is quadrilateral with two sets of consecutive, congruent sides. So it's going to oftentimes look like this, where we've got these two sides being congruent and these two sides being congruent. That is certainly different than the parallelogram family, where all the opposite sides were congruent. Some fun facts about kites that Euclid proved. First of all, is that if you've got a kite, if a quadrilateral is a kite, then the diagonals intersect at right angles. They are perpendicular. That is the perpendicular diagonals theorem. Next, we've got if a quadrilateral is a kite, then it has one set of congruent opposite angles. So when you've got your kite, these angles and these angles are congruent, but not the other ones. You've only got one set of opposite congruent angles, and it's these guys. It's the ones that are formed by the different side lengths. So not where the congruent sides meet, but where the different sides meet. Next, you've got the kite angle bisector theorem, which says that if you've got a kite, then it's got one set of angles that are being bisected. So this angle is being bisected, and this angle is being bisected. So those opposite angles are being bisected, but the other ones are not. Okay, so that's kind of weird. So it is the set of angles that are being formed by the congruent sides that are being bisected. Then we've got the kite diagonal bisector theorem. So with this one, what this is saying is that when you draw on the diagonals of the kite, one of them is being bisected. So this diagonal is being bisected, but the other diagonal is not being bisected. So that is where it's the diagonal connecting the 2 points where the congruent sides meet. The non-congruent sides are meeting. So it's not the longer diagonal, it's the shorter diagonal that's getting bisected. Okay, so let's try to solve some stuff using these little theorems here. Example 1 says solve for x and find the perimeter of the kite. Okay, so we can see that it's those sides that are the same, which means that it's these sides that are the same if this thing's a kite. So that just tells us we can do 4x minus 2 is equal to x plus 7. Subtract the x, we get 3x minus 2 is equal to 7. Add the 2, we get 3x is equal to 9, so x must be 3. Now, if we want to find the perimeter, we got to plug this thing back in. Let's plug that 3 back in. X plus 7, 3 plus 7 is 10. 4 times 3 is 12, minus 2 is 10. So it looks like for our perimeter, we've got a 10, a 15, and a 15. So our perimeter should be, what's that going to be, 20 plus 30, so our perimeter is 50. Also, when we plugged back in, our x worked, so we can give ourselves a check for checking our work. For this one, we want to solve for x, y, and z if this thing is a kite. Okay, so what do we have going on here? We need to find x, y, and z. Let's look at where x is. Now, if this is a kite, this angle is a right angle because the diagonals form right angles. So right away, I know that y's got to be 90, right? Because that's going to be another side of the 90. Now, also, one thing about kites is that we said that we got this one set of angles that are getting bisected. So that means this angle and this angle are the same. So this is a 46. And this angle and this angle are the same because those are the angles that are getting bisected. Like angle D is getting bisected, angle B is getting bisected. So what I'm looking at right now is this triangle. And I know the triangle sum theorem says that all three angles have to add up to be 180. So I know that x plus 90 plus 30 equals 180. That's 120. So x must be 60. That does mean that this angle is also 60 over here, if we wanted to know that. And then what I can do is I can do the same thing, but down here with this triangle. Because z is part of a little right triangle. So I could say that z plus 46 plus 90 equals 180. That's z plus 136 is equal to 180. Oh, I put an equal sign and a plus. So subtract the 136, and I get that z is 54. No, I'm sorry. That should be 44. No, it's 54. So I hope that problem was a good illustration of how the angles work in kites, because that can be kind of tricky. The way that it would end up being is that that'd be 44, this would be 44, and then we know all the angles, right? So hopefully you can see that this big angle, 44 and 60, is equal to this big angle. And then, like we mentioned, angle D and angle B, those are the ones that are getting bisected. And then angle A and angle C, those are the congruent angles. All right, we'll come back and do some kite stuff here in a little bit, but let's take a look at the trapezoid stuff now. So a trapezoid is the other non-parallelogram quadrilateral that we're going to be looking at. And a trapezoid is a quadrilateral with one set of parallel sides. So a basic trapezoid could look something like this, where all we really know is that these sides are parallel. So not a lot going on with the trapezoid. A common thing that you might see in a trapezoid, though, is a mid-segment of a trapezoid. So what a mid-segment is it is a segment connecting the midpoints of the legs. So when you've got a trapezoid, the two sides that are parallel are referred to as the bases, and then the legs are the non-parallel sides. So that's these guys. And so what a mid-segment does is it connects the midpoints of those legs. So it would look like that. So the mid-segment is this guy right here. Now, what's going on with a mid-segment? Well, if a trapezoid has a mid-segment, then it is parallel to both bases and equal to half the sum of the bases. So let me try to draw it again here. So let's get that mid-segment in there. So here's our mid-segment. And the way that it works is that it is parallel to the bases. So all three are parallel. And it's equal to half the sum of the bases. So like, let's say this is 10 and this is 20. Then 10 plus 20 is 30. Half of that is 15. So it's the average of the bases. Okay, and that's going to come in when we got some of those algebraic ones. Now, there are special types of trapezoids. And the one that we were talking about here is an isosceles trapezoid. So an isosceles trapezoid is going to be a trapezoid with congruent legs. So unlike the ones that I drew up above where the legs are different, an isosceles trapezoid is probably what you normally think about when you think about a trapezoid. So an isosceles trapezoid has the two parallel sides like a normal trapezoid, but then it also has these congruent bases. I'm sorry, the congruent legs. The bases are parallel, the legs are congruent. And there's two kind of cool things about specifically isosceles trapezoids. One of them is that if you've got an isosceles trapezoid, then the diagonals going from corner to corner are congruent. And they divide themselves up like this, where the top little parts are the same and the bottom little parts are the same. And that means that the entirety of them is also the same. The other fun fact, the other theorem that our guy Euclid proved about isosceles trapezoids is that the base angles are congruent. So if we've got our isosceles trapezoid here, then this angle and this angle are the same, and this angle and this angle are the same. So that's another fun fact about them. Okay, so a lot of random facts about the trapezoid here. We got to know the mid-segment stuff where it's parallel and it is half the basis. And then we got to know the isosceles trapezoid stuff where the diagonals are the same and the base angles are the same. Okay, so let's try to get some stuff going here. Solve for x, y, and z. A, B, C, D is an isosceles trapezoid, and E, F is a mid-segment. Okay. What are we doing here? Let's find, we got to find x, we got to find y, we got to find z. Okay, well, x is the mid-segment, right? X is on EF, that is the mid-segment. And what do we say about the mid-segment? The mid-segment is half the sum of the bases. So that means that if we do, so let's do 12 plus 14, get 26, and then do 26 divided by 2, and we get 13. So x must be 13. It's half the sum of the bases. Then for y and z, well, what I look at first is I know that these base angles are the same, and these base angles are the same. So I know that z is 70. That's easy. But to find y, we got to remember the basics of trapezoids. The basics of trapezoids is that the two bases are parallel. And so that means that we can just do 180 minus 70 to get 110, right? Those are consecutive interior angles or same side interior angles. And so they have to be supplementary. All right, and then last one here. So solve for x, y, and z. A, B, C, D is an isosceles trapezoid. Okay. X, y, z. What have we here? Well, I should know that this and this are the same, and this are the same, right? If this is an isosceles trapezoid, that's how those diagonals intersect each other. So x has to be 20, y has to be 15, and z, if this is an isosceles trapezoid, then these are those legs, right? So z's got to be 18. Okay, and that wraps that one up. So what do we have left? We've got a big isosceles trapezoid problem, and we got a big kite problem. Okay, so kite. Solve for x, y, and find the perimeter of the kite. Okay, so I'm looking at x first. X is one of the chunks of the diagonal. Now, what I know about the diagonals is that they form right angles, right? So what I'm thinking about is that this is a right triangle. And if this is a right triangle, then we could do the Pythagorean theorem. So that's what I'm going to do. I'm going to do a little a squared plus b squared equals c squared. That would be x squared plus 20 squared equals 25 squared. That's x squared plus 400 equals 625. If I subtract the 400, I get x squared is equal to 225. Take the square root of that, and I get 15. So x is 15. And then what about y? Well, if this is a kite and these two sides are the same, that does mean that it's got to be these two sides that are the same on the other side. So that means that I could do 4y minus 10 is equal to 2y plus 4. Subtract the 2y, get 2y minus 10 is equal to 4. Add the 10, get 14. So y's got to be 7. Let me plug that back in and make sure that that works. 2 times 7 is 14, plus 4 is 18. 4 times 7 is 28, minus 10 is 18. So that works. And then let's find the perimeter. All right, the perimeter is going to be 18 plus 18 plus 25 plus 25. That's 50 plus 36, that's 86. Okay. Last one, isosceles trapezoid down here, solve for x, y, and z. EF is a midsegment. All right, let's start with x. I see the x on the two bases and the midsegment, right? So our midsegment theorem said that the base is equal to half the sum of, the midsegment is equal to half the sum of the bases. So that means I could do 2x plus 11, that is the midsegment, is equal to the sum of the bases, which is 10x and x plus 8, divided by 2, right? Half the sum of the bases. Now, to get rid of that 2, I'm just going to go ahead and multiply the other side by 2. That's going to cancel this out. I'm just going to get 4x plus 22 is equal to 10x plus x plus 8. Right? 2 times the midsegment equals the sum of the bases. You could think about it that way also. Now, combining my like terms gives me 4x plus 22 is equal to 11x plus 8. If I subtract the 4x, I get 7x plus 8. Subtract the 8, now I get 14 is equal to 7x. It means that x is 2. Now let's just make sure that that works. If x is 2, then 10 times x is 20. 2 times x, 2 times 2 is 4, plus 11 is 15. And then x plus 8, 2 plus 8 is 10. So that looks good to me. 15 is right in the middle, 10 and 20. Now we still need to find y and z. So for y, I'm looking at these base angles over here. Those base angles have to be the same if this is an isosceles trapezoid. So let's do 4y is equal to y plus 60. Subtract the y, I get 3y is equal to 60, so y is equal to 20. Plugging that back in gives us 80 and 80, so that checks out. And then for z, well, z should be the same as angle B, or angle C should be congruent to angle B, but I don't know what angle B is, so I can't set those equal to each other. Instead, I got to remember that if those lines are parallel, then like angle D and angle C, they have to be supplementary. So I'm going to do 4z plus 80 is equal to 180. If I subtract the 80, I find out that angle C has to be 100, right? And then divide by 4, and I get that z is 25. All right. So these ones are a little bit odd. Their properties are kind of all over the place, but hopefully you were following along well. You got 6 problems to try down here on the your turn. So it is officially your turn. Try these out, and then come back for the video when you're ready to check to see how you did. All right, so this first one, isosceles trapezoid here, those two angles have to be supplementary, right? If those are the parallel lines. So let's see here, combine those like terms, we get 20x plus 60 is equal to 180. That's 20x is equal to 120, so x is 6. For this one, we got those sides being the same, we got these sides being the same. Let's do 5x minus 4 is equal to 16. We're going to make sure we're not setting it equal to 10, right? It's not the opposite sides of the same. This is 5x is equal to 20, so x is 4. For our kite here, if this thing's a kite, we should know that those diagonals intersect at right angles. So 8x plus 10 is equal to 90. That's 8x is equal to 80, so x is 10. For this one, if this is an isosceles trapezoid, then it's those bases that are the same and these sides that are the same. So let's do 9x minus 3 has to be equal to the 60, right? So we add that 3 over, we get 63, and x is 7. And if we wanted to find the perimeter, that other side over there was 70, so we'll add up all these. All right, 60 plus 60 plus the 70 and the 40. And what do we get? That's 120, 190, 230 is the perimeter. All right, this one, solve for x and db with this nice isosceles trapezoid. Okay, so this one's kind of tricky because we know that those two parts are the same and these two parts are the same. So if I want to find x, I need to make sure I do 3x plus 3 is equal to 18. Don't set it equal to the 4x plus 5 because those chunks are not the same in an isosceles trapezoid. This is not a rectangle. So that's 3x is equal to 15, so x is 5. And now we can plug back in and help find dB. So if x is 5, this is 18, this is 25, so dB needs to be 43. And in this last one, we want to find the perimeter. Well, if we want to find the perimeter, we got to know that set of sides, those should be the same, and this set of sides, those should be the same. So what I'm going to do is I'm going to put an x there and a y there. I'm going to do the Pythagorean theorem twice, since if this is a kite, that's a right angle. So I've got two little right triangles that I'm going to do the Pythagorean theorem for. Let's do the green one first, the x one. That's 9 squared plus 12 squared equals x squared. 81 plus 144 is equal to x squared. That's 225. So x is 15. And then for y, I'm doing 12 squared plus 16 squared equals y squared. That's 144 plus 256 equals y squared. That's 400. It's equal to y squared, so y is 20. So then my perimeter is going to be 15 plus 15 plus 20 plus 20. So that's 40 and 30. That perimeter is 70. All right. Hopefully that went well for y'all, and that's going to wrap up our video.